Alright, another great example, or L'Hopital rule. In this case, we try our luck with a little creature like this. If you try the plug-in method, you would get 0 to the 0, which you can quickly identify as one of the famous 7 indeterminate forms. The promise was that we can always take any one of these and tweak it using our excellent algebra skills into one of the L'Hopital friendly ones. This is L'Hopital land right here. So how would you tweak this one? You could use this famous trick here, and the famous trick goes like this. Let me think. The famous trick goes like, let me see if I can pull out my different program here. Yeah. So the famous trick goes like this. Anytime I have 5, for example, I could always rewrite 5 as e to the ln of 5. Why is that? Well, because the e and the ln would cancel each other out, and that would of course give you 5. There's nothing special about 5. I could do it for 7.13. That would be e ln 7.13. In fact, for any positive number x, I can always rewrite it as e ln x, so long as x is well behaved, maybe positive, so that you don't have any trouble here with a log. This is a famous trick. It allows you to write anything, blah, to, as well, not anything that's positive, as e to some power. We will use this trick exactly to write x to the x is equal to what was it? E to the ln x to the x. And what will that do to us? Well, we will use our excellent log skills, and that will become e to the x ln of x, and then we will use the fact that the limit as x goes to 0, x to the x from the positive side, it will be equal to the limit as x goes to 0 from the positive side of e to the x ln of x. And then we will use the fact that e is a continuous function, and so you can feed the limit to the inside of the continuous function, to the composition of the function. The limit can go up there as long as e is continuous at this limit, so long as that limit exists and is finite. Talk is cheap. What that means is that here, I'll just do it here. E to the limit as x goes to 0 from the positive side of x ln of x is equal to e raised to the limit as x goes to 0 from the positive side of x ln of x. And what does that mean? Well, if I try the plug-in method, let me just focus on this piece for a little bit, if we may. Let's just do a little color shift here. We shall focus our attention just on this piece, and when we're done with that piece, we'll come back and feed it in there. Yeah, does that sound like a plan? So yeah, let me just do it here. The limit as x goes to 0 from the positive side of x ln of x. If I just try the plug-in method, that would of course give me 0 times ln of 0 from the positive side, which would of course give me 0 times negative infinity. And by this point, this should look really familiar. We've just done an example. I don't know if you're watching these lectures in order or not, but if you're not, if you didn't watch the previous example, we said we can always tweak this form. This one we can always tweak into one of the famous forms for L'Hopital by just doing some algebra here. We do ln of x, and instead of writing x here, we write it 1 over x, the opposite of reducing complex fractions. And the advantage there is that when I try the plug-in method, now I get negative infinity over infinity as x goes to 0 from the positive side. And that's perfect for L'Hopital. I don't know, again, if you're watching the lectures or not, but if we try L'Hopital, we say this was 1 over x, this was 1 over x squared. The limit as x goes to 0 from the positive side, which we can simplify. The limit as x goes to 0 from the positive side, negative x, which was equal to 0. All this work was just so that we can go up there and plug it in 0. So therefore we switch back to our other color, yellow, and we finish this. This was equal to e raised to the 0, of course. And that becomes the famous just e to the 0, which is equal to 1. So that's it. It's nice, huh? Go back to this and you see that x to the x, again, can always, the promise was that you could always tweak it to be one of the indeterminate forms. So that's in fact what we did here. We wrote it as the limit as x goes to the positive side E ln x to the x, and the rest is history. We just did that, and that becomes 1. Okay, nice, huh? I told you. See what they paid me? Alright, come back for deep example. Another one. I know, huh? There's plenty more where that came from. Peace.